Hello, everybody. Today we're going to be solving LeetCode number 2 of the top 100, which is add two numbers. So you're given a non-empty linked list representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. So we need to add the two numbers and then return it as a linked list. So if we look at the example here, we'll see that we're given two linked lists. 2, 4, and 3, and then another one, 5, 6, and 4. And we need to add them together to produce a linked list that is 7, 0, 8. So the explanation here says that 342 plus 465 is 807, which is how we come to this answer. So basically what we're doing is we're reversing both of these linked lists, and then we're adding them together, and then reversing the answer. So how would we go about doing this? Let's take a look and draw it out. Okay. So if you look at the example here, you can see that to get 342 plus 465, we need to reverse both of these linked lists to get that number. But actually what we're doing here is if we're just adding these up, we can just start from the front of both of these lists, right? Because the first number in both of these lists represents the ones place. The second number in both of these lists here represent the tens place. And then the third number here represents the hundreds place. So as long as we're adding these numbers together, we can just build our linked list as we go, right? So if you look at this answer here, we have 342 plus 465 is 807. So the first number here that we would get would be 7, right? So that's just 5 plus 2. And so we'll build a node here, 7, and then we'll attach a node as the next node to 7. And then we'll increment through both of these linked lists here. Where we have 4 and 6, and we'll add them together. So this is one of the important parts of this problem is that when we get a number that's 10, all of these numbers have to be single digits, right? So we need to keep track of the carry number, we'll call that, right? So the carry number is either going to be 1 or 0. So if the number is greater than or equal to 10, then carry is going to be equal to 1, right? And if the number is less than 10, then carry is just going to be 0. So every time through this linked list, we can just add carry to both of these positions. So we'll have 2 and 7 plus carry, which will start out as 0, and that will be 7. And then we'll move to the next position in the linked list, and we'll say 6 and 4 is 10. So we need to carry 10, right? So since 6 plus 4 is 10, then what we'll do is we'll take the ones place of the 10 number, or the double digit number, and we'll put that in for our node here, and then we'll carry this 1 over to this next addition set that we're going to do. So then we're going to add 3 and 4 together plus carry, which is now equal to 1, and that's going to be 8. So that's going to produce the answer that we're supposed to get here, which is a linked list that goes 7, 0, and 8. So let's see how we would. Okay, well, so I guess first we should cover what the time complexity of this algorithm is. And the time complexity of this algorithm is just order n of the maximum length of these two lists, right? Because we have to, the most number of iterations that we're going to have to do is the longest list that we have. So if one of these lists was longer than the other, then that would dictate how many operations we need to do. So if we had a list that were 7 nodes long and we had a list that was 3 nodes long, then it would be order n, the length of the list that's 7. And so one thing that I forgot to mention is that if we have one list that has seven nodes in it, right? Or if we have a list that has extra nodes in it, so we have one, let's just say we have one that has 3 nodes in it, and then we have one that only has 1 here, right? So this would be the ones place. We would add these two together. Let's just say these are 1 and 2, and that would produce a node that was 3. Sorry, that the writing is really terrible. That would produce a node that's 3. And then here, if there's not a node present, then we'll just check to see if this value exists. And if it doesn't exist, then we'll just place a 0 there. So we'll always be adding a node value to either another node value or 0 plus the carry number. And if we do that all the way through, that should get us to the correct answer. Okay, so let's see what this would look like in code. All right, so add 2 numbers. So the first thing we need to do is we need to create a starting point. So we'll just initialize a head. So we'll say let head equal new list node. So we'll initialize a new list node as head, and then we need to create a pointer that's pointing to the head of our list, because as we increment through the list, if we don't initialize a pointer, we're gonna lose track of the starting point. And at the end of this algorithm, what we want to return is the head of the list. And as we move through it, we're going to be moving through to the end of the list when we finish. So before we start, we need to create a pointer. So we'll create a pointer we'll call it oHead for original head, and we'll just point it right back at the head that we're starting on. And so now at this point, okay, we also need to initialize a carry, right? So we need to keep track of the carry number that we talked about. So the carry number is going to be whether or not we need to add 1 to the next number. So the next thing we need to do is we need to increment through both of these lists, L1 and L2. So while there is still a value in one of the 2 lists, we need to keep looping through that list. We'll do a while loop, and we'll say while L1 or L2, right? So here we're just saying that if L1 is a truthy value, which means it's still an object, it hasn't incremented to null, then we want to keep looping over this list. And then what we want to do is we want to keep track of these 2 numbers. We want to set these 2 numbers so that we can add them together. So we'll say let num1 equal, and we'll say so we'll use a ternary here, and we'll just say if L1, then we want to set the value of num1 to be the value at that particular node. So we'll say if L1, then we want to use L1.val. Otherwise, we want to set it to 0, because if we're at the end of the list and we don't have anything left to add, then we just want to add a 0, because it doesn't affect the total value between the two lists. And we'll do the same thing for L2. So we'll say let num2 equal L2, or if L2, then we'll use the value at L2. Else, we'll just add a 0 to it. Okay, and then so what we want to do is we want to then add these numbers together. We want to add L1's value with L2 along with the carry value. So we'll let n be equal to the sum of the first number plus the second number plus the carry value. So what do we want to do here? We want to say if n is greater than or equal to 10, then we want to okay. So if n is greater than or equal to 10, we want to set the then head.next. So head.next is going to be equal to a new list node where, so this is the case where because n is greater than 10, we just want to take the single digit of this number. So if this was 19, then we would just want to store 9 here, and then we would want to carry the 1 over to the next value. So to do that, what we can say is we can say that we just want n mod 10. So that's just going to give us, that's just going to chop off the single digit and store it in this list node value. And then we would want to then set the carry equal to 1. Else, this means that n is less than 10. We just want to store the value in that node. So then we'll just say that head.next is equal to a new list node with the value of n, and then we will set carry. We'll set carry to be 0. So the last thing that we need to do here is we need to move the pointer of head to that new node that we created, because we want to keep pushing these nodes. We want to keep pushing these nodes out, right? Because we're starting. We want to reverse the number. So we want to store the 1's value at the beginning of the list, and then the 10's value in the next place, the 100's value in the next place, and so on. So what we want to do is we want to increment head to equal head.next. Okay, so that way we're always adding the number to the end of the list. And then so one more kind of edge case that we need to think about here is so this carry value if we end on a number that is greater than or equal to 10, then when we exit this while loop, we're still going to have one number left over. So we need to check to see if this carry value here is a 1. So if we end with this carry value as a 1, then we need to append it to the end of our list before we return the head of the list. So we need to check and say if carry, then head dot next equals a new list node with the value of 1, which is just the carry value. And then we can return the original head dot next, because we initiated this list with kind of just a dummy pointer. We don't want to include that in the answer, so we'll return head dot next. And that okay. So I forgot to do one thing here, and hopefully you guys caught it, but it's kind of a big one. But we need to actually increment these, or else we're not going to go anywhere, right? So we need to check and see if L1, which means that the L1 is still a list node, then we need to increment it and move it to the next place, right? So we need to say L1 equals L1 dot next. Then we need to do the same thing for L2. So we say if L2, then L2 equals L2 dot next. Okay, and that should get us the correct answer. So let's just see how we did. All right, great. So let's see. So I think this is probably the fastest way to do this this problem. All right, well, so we got 31%, but we're in the range here. If you, it's 120 millisecond runtime. This is the optimal solutions around 112. You can just see if we run it again, if we get kind of a better result. Okay. That's really, really bad. Okay, let's try this one more time. Well, anyway, I just kind of keep running it until I get an answer that makes me feel good, which I'm not really sure if that means anything. But this is definitely an order n solution, and to solve this problem, you have to look at every single item in the list, because you need to increment through and add up all the numbers. So there isn't really like a faster solution to do this, but we can maybe check and look at some of the other answers and see how they solved it. All right, well, let's just check out some of these other answers. Okay, so all right, so you can see here, this is pretty much exactly what we did. So they initialize a pointer or a list node, and then they pointed back at the head of that node, right? And then they also used a carry tracker, and then did the same kind of thing. Although this is kind of cool syntax, if L1 and L1 dot value. So this is just a way where you can actually use this and operator. You can say, if this thing is truthy, then it will just return this second thing to you. So if L1 is a truthy value, then it will give you the L1 dot val. Otherwise, it's going to be a 0, right? Because then this thing will evaluate to falsy, which will then give you the 0. So that's kind of a cool way to write that. And then they did the same thing here. They just sum up the two values and the carry value, and then they calculate the sum here. So they set the value to be the sum mod 10, which is what basically what we did. And then use this carry. They set the carry using a math.for of the sum divided by 10. So if it's greater than 10, then it's going to be that single digit number, or it's going to be a 1. And if it's less than 10, then it's going to be a 0. And then they're kind of moving the head just like we did and doing the same thing here, moving L1 along to L1 dot next. And that is the best solution on LeetCode. So I find it hard to believe that we're this far off, here. So I'm just going to run it one more time just to make myself feel better. I feel pretty good about the solution that we came up with. But feel free to comment and tell me if you come up with a better one. But let's just try it one more time. All right. Anyway, so this is, let's see. Anyway, this thing is nuts. It's so random sometimes, but I think you can see that we're in the ballpark here. So please join me next time when I solve LeetCode problem number 3. I haven't looked at it yet, but this was add 2 numbers. I hope you enjoyed the video. Thanks. Bye.